All right, friends, this is for the box method for multiplication. I'm gonna start with this. Let's say you have an example, 157 times 28. 157 times 28. So the way the box method works is, this is 3 digits by 2 digits. So I'm going to do a 3 by 2 box. There's my 2. Pardon my dog, like making noise in the background. He's like a cat, he's purring, I can hear him. Okay, so I did a 2 by 3 box here. 157 is really 100 plus 50 plus 7. So we're putting those in place values. Then we have 20 and 8. So what I ask my students is 2 times 1 is 2 with 1, 2, 3 zeros. 2 times 5 is 10 with 1, 2, 0. 2 times 7 is 14 with 1 extra 0. 8 times 1 is 8 with 2 zeros. 8 times 5 is 40 with 1 extra 0, that guy right there, and then we have 56. Now, we're gonna add everything up that's in here, and you can start to do some of this in your head, like 2,000 plus 1,000 is 3,000 plus 800, that's 3,800. And then 400 plus this, that's 540, and then 56. So if I add all these up, I get 6, 9, 8, what's that, 2, so 13, carry the 1, and I get 4,396. So 157 times 28 is 4,396. You'll start to get faster about adding things in your head, so that's why I encourage this method. Now, what about if we have something like 68 hundredths times 3.2? In this case, what I would say is I tell my kids to ignore the decimals till the end. You could do the box method with these place values, but I think it's easier to ignore until the end. So in this case, this is really 68 times 32, which is a 2 by 2 box. So let's say we've got this. I do that kind of weird. There we go. So there's my 2 by 2 box. I'm drawing enormous boxes so you can see them. You don't have to make them this big. So I have 68 and 32. 6 times 3 is 18 with 2 zeros, 1, 2. 3 times 8 is 24 with a 0. 2 times 6 is 12 with a 0. 2 times 8 is 16. So let's go ahead and add all these up in our heads. So we've got 1,800. 1,800 plus 16 is 1,816. So that's easy enough. Then if we add these guys, we've got 3, so 4, 5, 6, so 360. Did I make that right? Yeah, okay. 6, 7, 8, 9, 10, 11, carry the 1. We get 2,176. Now remember, I said we just ignore the decimals, right? So at the end, what we have to do is we count the number of digits that are behind decimals. 1, 2, and 3 digits behind decimals. So over here at our original number, remember, part of invisible math is if you don't see a decimal, then it's at the end. So I don't see a decimal here, so that's assumed to be at the end. I'm going to move it in 3 spots because there are 3 digits behind decimals. So 1, 2, 3. I get 2 and 176 thousandths as my answer. So when I say 68 hundredths times 3 and 2 tenths, that's going to equal 2 and 176 thousandths. Okay, one more that I want to show you. Okay, so for one more that I want to show you, this works well with fractions if one of them is a whole number. You can do it if you have fractions on both of them, but it takes a little bit longer, I think. It's easier just to turn them into improper fractions, multiply straight across top, straight across bottom, and then reduce or whatever you need to do. But if I had something like this, 27 times 2 and 1/3, I could use the box method for this as well. So what I would say is we're going to do 20, actually, you know what, instead of 27, what I'm going to say is 9 for right now, because you can do it with but I want to show you a little bit easier. This is a 2-digit, that's why I want to do 9. So what I would do here is say, okay, here's my 9, and I'm multiplying it by 2 and 1/3. So 2 and 1/3. Well, 9 times 2 is 18, and then 9 times 1/3. I always say fractions are side work. 9 times 1/3, I can turn anything into a fraction by putting it over 1. I can either multiply straight across the top, straight across the bottom, or I can cross cancel. Divide by 3, I get 1. Divide by 3, I get 3. 3 times 1, and so downstairs 1 times 1 is just 1, so I get rid of that. 3 times 1 is 3. So 9 times 1/3 is 3. Add these together and we get 21. So 18 plus 3 equals 21. So there's another use of that box method. Hopefully that helps.